Hello everyone, my name is Prashant. I am from CSC C section second semester. Today we are going to talk about multiple random variables, joint and conditional distributions. Introduction. Multiple random variables are a common occurrence in statistics and probability theory. Joint and conditional distributions are two important concepts when dealing with multiple random variables. Understanding joint and conditional distributions is crucial in many practical applications. Joint probability distribution. Joint probability distribution describes the probability of two or more random variables taking certain values simultaneously. A joint probability distribution can be represented by using a joint probability mass function or joint probability density function. The joint probability distribution satisfies the properties of probability, that is, non-negativity, additivity, and normalization. Marginal probability distribution. The marginal probability distribution of a random variable is the probability distribution of that variable alone, ignoring the other variables. The marginal distribution can be obtained from the joint distribution by summing or integrating overall possible values of other variables. The marginal distribution satisfies the properties of probability, that is, non-negativity, additivity, and normalization. So here we can see an example, the marginal probability distribution for x and y. Here we see that y is equal to number of times CT name is stated and x is equal to number of bars of signal strength 1, 2, 3. So for 4 we get to x is equal to 1 is 0.15, then 2 0.1, then 3 0.05. Then we get marginal probability distribution on y is equal to 0.3. So we get to calculate the marginal probability distribution of x. Conditional probability distribution. The conditional probability distribution describes the probability of one random variable given the value of another random variable. The conditional distribution can be obtained from joint distribution by dividing the joint distribution by marginal distribution of the conditional variable. The conditional distribution satisfies the properties of probability, that is, non-negativity, additivity, and normalization. Cumulative distribution function of discrete random variable x. The distribution function of discrete random variable x defined in minus infinity to infinity is given by f of x is equal to p of capital X less than equal to small x is equal to sigma of t less than equal to x f of t, that is, lie between minus infinity and infinity. So probability of distribution function is p of probability of a less than x less than equal to b is equal to f of b minus f of a. Probability of a less than equal to x less than equal to b is equal to probability of x is equal to a plus f of b minus f of a. Probability of a less than x less than b is equal to f of b minus f of a minus probability of x is equal to b. Probability of a less than equal to x less than b is equal to f of b minus f of a minus probability of x is equal to b plus probability of x is equal to a. Independence of random variables. Two random variables x and y are independent if the joint probability distribution can be written as the product of their marginal probability distributions. Independence of random variables implies that their conditional probability distributions are equal to the marginal probability distributions. Independence of random variables is a useful property that simplifies many calculations. Covariance and correlation. Covariance measures the degree to which two random variables are linearly related. Correlation is the normalized version of covariance and measures the degree to which two variables are linearly related while scaling out the effect of their variances. Covariance and correlation can be used to measure the strength and direction of relationship between two random variables. So here for example, covariance and correlation measure linear association between two variables, let's say x and y. So for covariance, population parameter sigma x comma y is equal to sigma of y of I minus mu of y into x of I minus mu of x by n. So properties of covariance and correlation. Covariance is a measure of linear association and symmetric. Covariance can take any value between minus infinity to infinity. Correlation is a dimensionless quantity and takes values between minus 1 and plus 1. So probability of joint probability distribution. The joint probability distribution of two random variables is a function of two variables and is symmetric. The joint probability distribution is non-negative and integrates to 1 over the support of two variables. The joint probability distribution determines all the marginal and conditional probability distribution of two variables. Conditional expectation. The conditional expectation of a random variable y given another random variable x is the expected value of y given the value of x. The conditional expectation can be calculated using the conditional probability distribution and the expected value of y. The conditional expectation satisfies the properties of expected value, that is linearity and monotonicity. Conditional variance. The conditional variance of random variable y given another random variable x is the variance of y given the value of x. The conditional variance can be calculated using the conditional probability distribution, the expected value of y and the expected value of y squared. The conditional variance satisfies the property of variance, that is non-negativity. Conditional distribution examples. An example of conditional distribution is the probability distribution of the height of a person given their weight. Another example is the probability distribution of a temperature given the humidity. Conditional distributions are useful in many practical applications such as weather, forecasting, finance, and healthcare. So the conditional distributions tell us that there is a difference in class for those who survived and for those who perished. This is better shown in the charts given here. Joint distribution example. An example of joint distribution is the probability distribution of the number of heads and tails while flipping two coins. Another example is the probability distribution of age and income of a group of people. Joint distributions are useful in many practical applications such as risk assessment, decision making, and quality control. Joint probability distribution. The joint probability distribution of two variables is equal to bivariate probability distribution. The joint probability distribution of two discrete random variables is usually written as p of x is equal to x, comma y is equal to y. Marginal distribution example. Marginal probability distribution. An example of marginal probability distribution is the probability distribution of the number of heads in two coin flips. Another example is the probability distribution of the age of people in the group. Marginal distributions are useful in many practical applications such as demographic analysis, market research, and medical studies. Covariance and correlation example. An example of covariance and correlation is the relationship between height and weight of people. Another example is the relation between the sales and advertising expenditure of a company. Covariance and correlation are useful in many practical applications such as data analysis, portfolio management, and sports analytics. Here we can see different graphs between correlation. Conditional expectation and variance example. An example of conditional expectation and variance is the expected value and the variance of the height of the people given their weight. Another example is the expected value and the variance of temperature given the humidity. Conditional expectation and variance are useful in many practical applications such as risk management, insurance, and engineering design. Joint and conditional distribution summary. Joint and conditional distributions are important concepts when dealing with multiple random variables. Two joint distributions describe the probability of two or more random variables taken certain values simultaneously. Marginal distributions describe the probability distribution of random variable alone, ignoring the other values. Covariance, correlation, expectation, and variance summary. Covariance measure the degree to which two random variables are linearly related. Correlation is the normalized version of covariance and measure the degree to which two variables are linearly related while scaling out the effect of variance. Conditional expectation is the expected value of a random variable given the value of another random variable. Importance of joint and conditional distributions. Joint and conditional distributions are important in many practical applications such as data analysis, finance, engineering, and healthcare. Understanding joint and conditional distributions is crucial for making informed decisions based on data. Joint and conditional distributions are fundamental concepts in probability theory and statistics. So, key takeaways. Joint and conditional distributions are important concepts when dealing with multiple random variables. Covariance, correlation, expectation, and variance are important measures of the relation between random variables. Joint and conditional distributions are useful in many practical applications and are fundamental concepts in probability theory and statistics. Thank you. End of slide show. Thank you.